Hey y'all, Data Guy here. And today, what I'm going to be doing is running you through a way that you can do true data streaming with Spark. And if you're looking for a way to run Spark locally or use Spark or anything, I have previous videos on that for either running just Spark application or running Spark Dockerized. This video is going to be specifically about creating a recoverable network word count application using PySpark streaming. So it's going to demonstrate to you how to create a streaming context, how to perform operations on streaming data, and then how to utilize broadcast variables and accumulators. So a lot of good foundational knowledge here around how to use Spark for data streaming and also performing operations on streaming data, doing transformations, all the good stuff around that. So to get started, what we're going to do is just go here, create a new file called Spark data or word count stream dot py. Then, so first we're going to do just import our packages like we do with everything with Python. So we're importing datetime, OS, sys, just so we can interact with system and operating system, typing. This is just easier ways to interact with lists and tuples. So just nice little quality of life packages. And then under the PySpark side of things, we're going to need a few different packages. So obviously, going to need Spark context to interact and with a current Spark contest context. Then we are going to need a PySpark accumulators library. And accumulators, if you don't already know what they are variables that are only added to across tasks in a distributed data set and then are brought back to the driver program. So they're only additive, and this means they can be used to implement counters like in MapReduce or sums to sum up the amount of tasks or the amount of really anything. And Spark natively supports accumulators of numeric types, and then if you want to add a different type, you're very welcome to do so, but mainly just high level use for aggregating information across a cluster, like the number of errors across different nodes or summing up metrics in a task across tasks. Then we also have this PySpark broadcast library, and broadcast variables allow you to keep a read-only variable cached on each machine rather than shipping a copy of it with every single task. So just read once, write multiple places, or read only, and then many different places can read from it rather than needing to actually have it contained within themselves. And this gives every node a copy of a large input data set in an efficient manner. So while the example of just a single variable seems small, you can also have this for larger data sets, which means every single worker can access the data set without needing to install it on that individual worker node, which is really useful for distributing large data sets that are needed by all nodes for tasks like lookup tables, dictionaries, or any really large data structure. Um, then RDD, we also have, which is a resilient distributed data set, which is a fundamental data structure within Spark. And this is an immutable distributed collection of objects that can be computed on in parallel. And RDDs can contain any type of Python, Java, Scale objects, user-defined classes, whatever you want to add. And RDDs are really used for performing computations, again, in a distributed manner, allowing users to perform map, filter, and reduce operations across a data set, which is distributed across a cluster. Might be getting a theme here. Spark's all about distributed computing, and these basically kind of bring you out of that Spark just 101 into real production grade ways to interact with and use Spark for what it's best at, which is distributed computing. And then finally, just streaming context, similar to Spark context, just the main entry point for streaming functionality. And this just includes all the methods we need to create data streams and represent continuous streams of data. So next thing we're going to do is actually register a broadcast variable. So in this case, what we're going to do is basically a function that's going to check if a broadcast variable named word excluded list already exists. If it doesn't, it's going to create a new broadcast variable containing a list of words to be excluded from the word count. And broadcast variables are used to basically just distribute, again, large values across all worker nodes. So this is going to basically take a list of broadcast variables that's going to say, any list, any word here in ABC is going to be excluded from our word count. So this is basically just kind of our whitelist for words that we know don't have any real meaning here. Then the next thing we're going to do is register an accumulator. So here, get drop words counter. So this is going to be a counter of all the words we're going to drop from the network, the data stream of words that we're taking in. So here we have drop words counter, just initializing a accumulator, not really doing anything with it here, but just having a place to count all the words that are dropped through the course of this function over the many different iterations that it's going to run. And then what we're going to do is create context. So here we're going to create our Spark streaming context. So initialize kind of that Spark streaming session, print, and this is going to just create a new context. OS exists. Then we're going to just print the current output path that's Spark is running in. And if not, we're going to set the Spark streaming context to our app name, Python streaming recoverable word count, word network word count, streaming contest SC1. Then what we're going to do is create a socket stream on the target IP port and count the words in an input stream of delimited text. So here, what we're going to do, this function is really responsible for creating, again, new streaming context and setting up just the basic streaming computation logic, which is going to first, again, check the specified output path exists. So if a output path for our results don't exist, then we're going to delete it. Or already exists, we're going to delete it because we want each run to produce idempotent data and not interact and interfere with the previous run. And then this one here is basically just saying, hey, this is going to be a 1 second batch interval. So every 1 second, our data is collected and processed. And this goes along with the idea that, hey, streaming is just really fast batching because that's in fact what we're doing here. We're doing really fast batching of data from listening to a particular endpoint. So here we're going to define that endpoint, the target IP port. So here, basically just setting up a socket text stream that listens to a specified port name. And then this is the source of streaming data here. And so what's happening here is this stream of lines that's coming in from our host and port are being split into words, and then the word count is performed by mapping each word to a count of 1. And then we're reducing the key, which is the word, to just basically give us a sum up of the count of the amount of words that are coming in the particular stream. And then what we're going to do next is kind of develop a function within a function to actually tabulate this and exclude any words that we don't want to actually register. So here, this echo function is going to be a callback for every single RDD in the stream, so every single resilient distributed system. It's going to filter out the words based on the exclusion list using that broadcast variable we set up, and then update the drop words counter using the accumulator that we also set up. And so it's going to append the counts and a summary of the drop words to the specified output file. So here under define echo, get or register the exclude list broadcast and set our accumulator. So here RDD context to get the word exclude list and the drop words counter. And again, because we've set these as available across all of our nodes, that's what we can call this. And then we are going to use the exclude list to drop words and use the drop words counter to count them. So here for filter function, so word count, tuple string integer, the word count in the exclude list is any of these values, so A, B, or C, then drop that word and add 1 to the drop words counter, and then return false, otherwise return true. And that just means we're kill the function, or not kill the function, but just you don't need to actually record anything within the drop words counter. Now, after this, what we're going to do is define the counts. So after it's gone through this filter function, counts at a particular date and time, so taking the current date time, taking the current counts, printing the counts of these words, drop words, and then this is giving you the current amount of drop words. So this is imagine like your Twitch, right? You want to filter out certain words. You want to figure out how many words you're filtering out in a text. This is something you'd use. You'd say, hey, I want to exclude all swear words from this stream. And so this is something you use to keep track of how many swear words you excluded over time. So then you can print the counts, drop words, appending to the output path. And then what it's going to do here is just write the results of how many drop words there were, what the current counts are, to an output, to a file, which we're just going to call counts. Then we're going to call this function, or this echo function, from word counts for each RDDD echo. So just saying for every single distributed node, run this word count and tabulate it up. And then our final section is checking for correct number of command line arguments. So here within this main block, you have again, do we have the proper host name, port, checkpoint directory, and output file? And then we're also going to try to recover a streaming context from the checkpoint directory if it's available. So there's already streaming context that exists. We're going to use that. Otherwise, we're going to create a new context here using our host port and output. And then we're also going to start the streaming computation and then wait for streaming to finish with await termination. And there you have it. Just a really simple way to use Spark, PySpark streaming for stateful and fault-tolerant stream processing. So just input whatever host, whatever port you want to listen to, and then you can listen to any output messages from that, take count of the words, adjust for what you want to filter for, using those broadcast variables for efficient data distribution, accumulators for global aggregation, and RDD transformations and actions on streaming data. And also having kind of these checkpoints for recoverability so we don't have to keep creating new sessions. And that is all I have for you today. I hope you found this video helpful. I hope you enjoyed it. And let me know if you have any ideas for future videos down in the comments below. But above all else, have a great rest of your day. Data Guy out.